Hello and welcome everyone. Good afternoon, morning or evening, whatever it is for you, wherever you are. And welcome to our live stream today. My name is Michaela and I'm a developer advocate at KX, and I'm going to be your host for today's session, which is going to be all about managing KDB architecture. And we're going to be learning about best practices for designing, managing and optimizing your KDB systems. And I'm super excited to have two guests today join me. We've got Cynthia and Alex. You guys want to say hi?
Hello.
Great. So for those of you who don't know, Cynthia is a solutions architect at KX, and she's got over 10 years experience building and supporting KDB solutions for some of the world's biggest financial institutions. And Alex is also a very seasoned KDB developer, currently at Data Intellect, and he's also a blogger and founder of the DEFCON Q blog, which is a really amazing KDB tech blog where he shares all his expertise and insights with the wider community. And I'm really excited to have you guys both join me today. Just before we dive into the fun stuff, I want to mention for anyone watching live, please do submit any questions you have through your chat, whether you're on LinkedIn or YouTube, and we can answer as many as we can throughout the session just to keep it as interactive and informative as possible. So I think we'll have a mixed audience today. Some of you might already have some experience with KDB. For some of you, it might be your first time hearing about it. So don't worry, this session is for everyone. If you do want to comment now, just letting us know what your experience level is. If you've used it or if you're kind of new to it, let us know so we know who we're talking to. And just secondly, this is being recorded and it's going to be available on our YouTube channel immediately afterwards. So in case you have to leave early, or if you want to share it with any friends or colleagues who may have missed it, feel free to do that. So with that said, I think we can get started into the content. So for anyone who is joining us with maybe limited or no experience at all with building KDB architectures, I wanted to start off by sharing that we have a brand new course on this topic available for free right now over on the KX Academy. So it covers the basics and will help you build a solid foundation in building your KDB architecture from scratch. And it's been designed to really take you from zero to a fully functioning KDB system, teaching you how to capture real-time data in as little steps as possible. So in that course, we start with a quick start, which provides like a conceptual overview of KDB architecture. There's instructions in there for launching your own KDB setup, which you can follow along with me in the videos and on the sandbox provided. So there's no need for you to have anything installed on your side to do that course. And then the rest of the course delves deeper into the core components where you learn how to customize your architecture by doing things like adding data feeds, implementing custom streaming analytics, learning about the end of day behavior, data retrieval, and setting up query gateways for improved user interactions. So again, we created that for all levels. So even if you haven't got much experience in the Q language, we teach you that as you go throughout the course and provide extra resources for that. So yeah, today we'll be building on these concepts covered in this course. So if you haven't checked that out, I highly recommend doing so afterwards. It will really give you a nice solid foundation in what we're going to talk about today. So just to recap really quickly on what the basic, or otherwise sometimes known as vanilla KDB architecture looks like. So firstly, there are some external processes here in black. So these include the data stream that's coming in from the upstream source. So that could be exchange market data in a financial application, or it could be sensor readings in a manufacturing application. And they're often in proprietary format. So then we have a feed handler, which converts that upstream data into a format suitable for writing to KDB. So they're usually written in a compiled language such as C, C++, or Java, but they can be written in Python or Q as well. Then internal to the data capture system is everything in yellow there. So we've got the ticker plant, first of all, which is usually the first port of entry to your KDB architecture and probably considered the most important component. And this process receives the data via the feed handler, and it's responsible for publishing this data out to any processes or subscribers that are subscribed to it. And one really important thing that we're going to talk about in detail later is that the ticker plant also logs all the incoming records, which maintains a backup in case any processes go down or we have a failure of our system. Then after the ticker plant, we have the RDB system. So that process is responsible for keeping a record of all today's data stored in tables. So it can be very lightweight and straightforward, and that subscribes to the ticker plant, meaning that every new record that comes in to the ticker plant is going to be updated in the RDB table. And then in a basic setup, typically at the end of each day, the RDB will purge its data and save that down to disk, clearing out its memory so that tomorrow it's ready to capture all that intraday data for the next day. And that historical data stored on disk can then be mapped into memory by a historical database process as and when it's needed. So having your queries for your historical data run in that separate process means that your memory and your performance of the RDB, which is concerned with the intraday data, is unaffected. So that's just a very quick overview of the core architecture. We are going to talk about these things in more detail with Cynthia and Alex, but I just wanted to kind of lay the land before we do. So I think we can dive in and start talking about some of these things and how we can enhance these things and build on them to kind of build the real life use cases that some people might do in the field and in practice. So Cynthia, do you want to kick us off talking about the next component we have here, which is real-time processing?
Yeah.
What it's used for?
Yeah, thanks, Michaela, for the introduction. So like we can see on the architecture diagram, I'm going to start speaking about the real-time subscribers, sometimes also known as real-time engine, complex event processor. Like you can find really many different names out there. I like to call them real-time engines or RTEs. And like Michaela said, the purpose of these processes is usually to do some job with data that's coming in real time. I like to think of them as almost like little workers that you have in your architecture that will be doing different jobs in your data application. Because you kind of know once you have an RDB or a HDB, you know really what the purpose of those are, and they will follow standard procedures. But for the real-time subscribers, they will do whatever you require them to do. And depending on the use case and the type of application that you're designing or developing, these processes could be doing many different jobs. So for example, if we were on a surveillance use case, you could have these real-time subscribers subscribing to different market data or trade data and running scenario logic, and then eventually, trigger an alert to say a certain rule was broken. Or for example, you could use it as data quality checks. So you could subscribe to your data, run certain data quality, and that way you can filter your data out so that further downstream in your application, you're only using good data, I guess, that you have filtered. So really what a real-time subscriber is, you will define what type of data you're subscribing to, you will define what type of job you want it to do, and usually you will publish something, again, either to a different real-time subscriber or back to the ticker plant for other processes to subscribe to. And usually you will end up having, more than just one. So again, in this architecture diagram, we only added one, but if you think of really big applications, you will probably have more than one. Even one subscriber could be doing multiple jobs. So depending on how much processing power every job requires, you may be able to, consolidate multiple jobs into one process. So you really need to monitor this process to understand, how busy it is. Do you need to break down this job into multiple processes? And yeah, I guess I wanted to explain my first time building a real-time engine. I started my KDB journey, and on the first couple of years, I was mostly in projects where I was just building analytics or, stored procedures. So dealing with the data after it had been captured and stored into the database. So I would mostly just use QSQL, and I would build my analytics and just dealing with the data and, extracting value that way. And then eventually I joined a project where we needed to build an algo trading platform from scratch. So everything was in real time. And it was my first time, dealing in practice with this type of architecture and having to deal with the data in real time. And, it was very interesting to see because it is a mindset shift that you have to do if you're used to, querying the data and joining multiple different data sets once they are in the database. It's very different when you're dealing with the data as it's coming in, streaming in. So it was really interesting for me, and it was really at that point where you sort of understand how much more power KDB can have when you drive value before it gets into the database. There's so much you can do. And then you can start playing around with things like, if you have reports that run at the end of the day, you could even start playing around. Like, what if I build, this derived data set instead of at the end of the day as a report? What if I build it in real time by adding a real-time subscriber and building on that derived data set as the data comes in? So it can make your system more scalable and also more performant. So for me, it was a good point, I guess, thankfully early in my career where I dealt with that. But I'm aware that not everybody has that chance. But yeah, I would really recommend, taking a look at your architecture and see, is there any more value that you can extract out of your data by adding this type of processes?
Amazing. And you mentioned there like a mindset shift. Do you find you work a lot with our customers building these architectures? Maybe they're coming without the experience. Do you find that's something that takes them a while to get their head around?
Yeah, because especially if they're used to other type of technologies where you'll deal with the data when it's already in the database. So sometimes it's hard to explain. It's like you can subscribe to the data and deal with a lot smaller data sets as it's coming in, and build out the logic that way. And even the way that you write your code is a little bit different, right? You understand the logic, you understand the angle, but it does take a little bit of changing. But once you understand, it's really not that hard.
Awesome. Anything to add, Alex, there about your experience?
No, I agree with what Cynthia said. It's actually quite interesting to develop those real-time subscribers. I myself had the chance to work on a project that was doing some analytical calculations, and we would subscribe to the ticker plant, and then in the analytical process, we were doing some metrics for the traders and for the quants in real time. And you don't always necessarily need all the data that the ticker plant is publishing. So as opposed to a real-time database that captures the whole intraday data in memory, the real-time subscriber that does the analytical calculations might only keep like a last value cache or some metrics that are calculated on every update or every n updates. So it's actually quite interesting to write one of those CPs, complex event processing engines, and do some analytics in real time and see how what your build can have an impact on how the quants or the traders are actually trading or like conducting their business. So it's quite interesting and challenging.
Yeah. Cool. I think we can move on and talk about another vital component of the system. I might get you to start with this one, Alex. So this is all about gateways and even load balancers, ensuring that you've got your system efficiently built. So do you want to explain the role of them a bit more and why they're important in your experiences?
Yeah, sure. So the gateway, like it's, in my opinion, like a very important process in a KDB tick system. And it's one of the first things I would add when I start building out the vanilla tick setup to enhance it. Basically, how I see the gateway is as the entry point to your tick system for the user. The reason why you want to have a gateway in between your real-time database and historical database is for like quite a few reasons. So first of all, your user might not always know where the data sits. Like I often see business users being confused about the difference between the RDB and the HDB. Like it's like for them, it's often too much details. Like the RDB contains intraday data and the HDB contains historical data. And the user often doesn't actually know about this difference. So instead of like sending a query to the RDB or sending a query to the HDB and wondering why they are not getting the data they are looking for, we can simply have a gateway and a gateway API, customized gateway API that simply routes the query that the user is sending to the gateway to the correct process in the background to fetch the data they're looking for. Another nice feature about the gateway is, like, let's say a user wants to get the last 10 days of trading data, including today's data. So if you don't have a gateway, you would have to send the query for the intraday data to the real-time database and the query for the historical data to the HDB. And then you would have to aggregate this data and send it back to the user, or the user would have to query both processes independently and then merge the data accordingly. But if you have a gateway API that does that for you out of the box, then the user doesn't need to worry where they get the intraday data from, where they get the HDB data from. They can simply call the API on the gateway process, and they will get automatically all the data back. Another reason, and this is a very crucial one in my opinion, is often your end user is not fluent in KDB. They send bad queries either to the RDB or to the HDB, and especially in production, this is very, very bad. Like, you have someone sending a select from trade query to the HDB, and you have 20 years worth of data in the HDB, and there goes your HDB and it's down. So on the gateway, you can actually implement some security checks around the queries the user sent. You can make sure there's a date clause. You can make sure there's no bad query. And instead of sending it to your HDB, you can simply block it and send back an error to the user. Another thing worth mentioning, permissioning or authentication. On the gateway itself, you can already implement a check whether the user is supposed to access this data, rather than letting the query go through an RDB or an HDB. And the gateway can also work as a load balancer. Depending on how you implement it, you can add load balancing functionality. So you can have several HDBs, and the gateway will load balance to the one that is the least busy at the moment. I think that's pretty much it. Also, for all other applications, I would recommend using a gateway rather than sending queries straight to the real-time database or HDB. Like, if you have like a UI that is using data, fetching data constantly, send it through a gateway, and the gateway can then collect the data and send it back to the UI rather than going straight to an RDB process or an HDB process. Yeah, I think that's pretty much it in terms of gateways.
Yeah, you covered a lot there. I heard we're trying to summarize everything now. So for routing the query, so the user doesn't need to know about the process that's underlying and they can't do any damage. Obviously, load balancing, security, and managing permissions. There's another one as well that I've come across, which is caching the data. So I was in a project where we had a Tableau front end, and we couldn't manage how many times the users were requesting that API, but often it was the same like data set that was required for the dashboard. So we would cache that in the gateway process for X amount of time. We find that quite useful too. Anything from you, Cynthia, to add?
You stole the caching point that I wanted to bring up. But yeah, I think also looking at how to scale, as you add more users into the application, sometimes you may see that this gateway becomes the bottleneck because it needs to handle a lot of requests. So just looking at how you're dealing with those queries and what is synchronous, what is asynchronous, that's another point that, as your application grows and more users get added, that's something that you would look at.
Yeah, and seeing what those users, like logging what those users are running, to then push those analytics down to the real-time subscriber if it's required as well. So lots you can do with your gateways. Let's move on. Oh,
sorry. One more thing that came to my mind is, like, often, like, when you don't have a gateway, users would hard code your connection to an RDB or an HDB, and then maybe you migrate your RDB or your HDB to a different port or different servers, and then suddenly the applications of the user are crashing or no longer working. But if you send everything to a gateway instead of hard coding it, you can just, using config files that the gateway retrieves the location of your RDB and HDB, from a config file, and the user doesn't need to worry about which server, which port does my RDB, my HTTP run on. So that allows for a lot of flexibility, especially when we talk about scalability and, you know, extending your system.
Yeah, definitely. I think that actually leads nicely into the next one we had. The next slide was when things do go wrong. When people do that query to the HTTP over 20 years of data and the thing comes crashing down, what next? What can we put in place to manage that? So yeah, Cynthia, do you want to start this one off?
Yeah, definitely. I guess just a point to start, you know, we have the title here, disaster recovery, which can mean a lot of things. We're going to focus today just from a KDB process perspective and maybe a little bit from an application perspective, but there's so much more you would need to consider because there can be many different types of disasters. We do have a white paper that goes into a lot of detail on, you know, multiple different scenarios, and that's usually what you would do when you are designing an application. But I guess for today, just to stick a little bit more into the basics, we'll just talk about from a process perspective. And obviously, just like the box that is highlighted, you know, we have that ticker plant log file, which is quite critical for being able to recover the data that you have been capturing during the day that's still not stored on disk. But, you know, when you're designing the application and you're thinking about all of the things that could go wrong, that sometimes you forget to think about this until a problem happens in production, and then you have to go back and actually look at how do we prevent this from happening, or how do we recover if it happens again. So I would encourage you that if you are designing or adding a new process to your architecture, and you usually will have a checklist, you know, of things that you will do when adding that process, that recovery is always part of that, right? So if I'm adding this element into my architecture, and something goes wrong and this process stops and has to be restarted, what has to happen? And then you will think, what's the role of that process? For example, taking the easy one, which is the RDB, you know, if that process has to be restarted, you want to be able to have all of the data that you have in memory, you want to have it again in memory. So, you know, the easy configuration is you will just replay that ticker plant log file back into memory, and then that side is sorted. But if we talk about, for example, a real-time subscriber, you may not be keeping any data in memory, or only a very small subset, like Alex was explaining earlier. So you may not want to replay the whole ticker plant log file. So there's things you can do as part of the startup of that process to, you know, define what your recovery logic would be. So there's a lot of flexibility here on what you can do, and it will usually be driven by different factors. One being, how much data do I need to recover, you know, in terms of volumes, how frequently that data changes, because it doesn't change that frequently, then my recovery strategy may be different. And also, how long can I afford that recovery to be? Because maybe you have a process that you needed to restart straight away, so then you needed to be able to recover really fast, and some others maybe are not as critical, so then you can allow for a little bit more time. So I guess just to give some examples of what I found, and then maybe Alex, you have more. I guess obviously replaying the TP log file, that's the standard one. But we found others where you would store the data that you're keeping in memory. You could store it on a flat file on disk, and then if the process restarts, it will read that table back, and then that recovery is pretty fast. But obviously you don't have a TP log file, so you may have lost data. So again, that's why it's important to understand, you know, what can you afford on that disaster recovery scenario. Or there's some other strategies that I've seen where you will connect to the RDB or to the gateway and get the data that you need, so that you can then restart from scratch, restarting your subscription to the ticker plant and start subscribing to that data again. However, I did have a scenario where we had multiple processes where the recovery was done by connecting to the RDB and getting that data. And if you think about that from a one process perspective, that's fine, right? That process will restart. we get the data from the RDB and that's okay. But we had a scenario where we had many processes doing that at the same time. So obviously that caused an issue because we had multiple processes trying to get data from the RDB, which was a single process. That caused a bottleneck. So I guess when you're thinking of that strategy on the recovery, it's important not to think only about that specific process, but also what's the impact to the rest of the application and what happens if this process is down, but also what happens if everything has an issue and how do you recover from that.
I guess for different customers or different use cases, different parts of the architecture is going to be more important to them at certain times. So yeah, understanding all of that is really crucial. Thanks so much, Cynthia. So many insights there. Alex, do you have anything to add or any horror stories? Maybe.
I wouldn't say horror stories, but I agree with Cynthia. The bigger your system gets, the more complex and more data you have, desto harder becomes disaster recovery. Like what Cynthia said about like going to the RDB first to recover the data it's a good approach, but as she mentioned, the more processes go down and when they restart, they try to recover the data from the RDB, then your RDB gets pretty busy and that might impact other users who actually need real-time data. So it has to be, on a use case by use case, you need to design your architecture a little bit differently and to the needs, what you want to get out from your system and what's the main focus on.
Awesome. We do have a question just before we move on. Maybe one of you want to take. So Alex has asked, is a gateway generally a thin wrapper only concerned with abstracting the RDB/HDB, or is it more like a complex service or an app in its own right?
Yeah, I think I can go for that one. So basically, like if you look at the architecture on the screen and that Michaela has put on there, basically every yellow box is like a KDB process on its own. So I wouldn't say they are like an app, because like to me, like an application is like, it would be the full system. But it's more an independent service, and it's also more than just a wrapper around an RDB or an HDB. It's a service that, or a KDB process that provides different functionalities to the RDB and the HDB. The RDB has the intraday data and the HDB has the historical data. The gateway, on the other hand, provides load balancing and query functionality. You can have a gateway API where you design the logic of the API, and that code is only loaded into the gateway rather than being loaded in the RDB and HDB as well. And I see it as, I try to keep my all the different KDB processes as lightweight as possible. Like give them one task and let them do that task efficiently and good. So I wouldn't say the gateway is something complex. It will have certain functionality that seems to be a little bit more complex than other processes, but I wouldn't over-engineer a gateway and make it do too much. I will try to keep it to load balancing and query routing and aggregating the data when it comes back, but that's about it. So I hope that answers the question.
Awesome. Yeah, thank you so much. I think we'll move on now to another important aspect that isn't in the basic setup of a KDB architecture, but quite often people then move to this when they're seeing things like slow subscribers, for example. So I think, Alex, do you want to start maybe telling us a bit about why you would use these and how they can help your system?
Sure. So chain decoupled is really, it's very similar to a normal decoupled, with the main difference, it's basically, it sits after or behind the decoupled, depending on how you want to look at it. So we use chain decoupleds to prevent slow subscribers bringing down your main decoupled. Now, what is a slow subscriber? In very simple words, it's basically just a real-time subscriber that cannot consume data as quickly as the decoupled publishes the data. Now, in the scenario we have on the screen, let's assume the real-time subscriber, as Cynthia explained before, does some analytics, some calculations, and this calculation takes longer than the Decaplant takes to publish your data. So by that, you're basically adding a delay on the real-time subscriber in consuming the data that's coming from the Decaplant. Now, that will cause the Decaplant to have an increased output queue, and at some point, the memory might spike so high that the Decaplant will crash. And that's pretty much the worst scenario that can happen. You don't want the Decaplant to crash because the Decaplant is the entry point for your data. It also logs the data to the log file. And if it goes down, you might not have a recovery mechanism. That then depends whether the feed handler also logs or keeps track of the data that has been sent to the Decaplant. So in order to avoid that scenario is we design a chain Decaplant that is pretty much a subscriber to the main Decaplant, and all slow subscribers, all real-time subscribers that take more time to consume the data you're publishing can subscribe to that chain Decaplant. You can then batch the chain Decaplant, meaning that you don't send every message as it comes in, but you wait for either a certain time period or a certain number of messages that the chain Decaplant receive. That depends on your design, and then you can publish the data to the real-time subscribers that actually subscribe to the chain Decaplant. So basically, it's just a safety mechanism, a safety net for your application to avoid that the main Decaplant gets too much load or gets backed up by slow subscribers and then crashes.
Thank you so much, Alex. Yeah, I think that kind of covered it all, unless Cynthia, do you have anything to add to that?
No, I think Alex covered everything there.
Awesome. So let's move on to another addition that you can have. Sorry, I did have some words there on the screen, just explaining what Alex had there. But yeah, the next kind of topic or flavor, I think we did mention Intraday Writedown when we were talking about gateways, but Cynthia, do you want to talk a little bit more about it in detail for us?
Yeah, sure. So the Intraday database, as you can see on the architecture diagram, it's basically adding another tier to your database. So up until now, we've been talking about the real-time database holding all of today's data, and then the historical database holding everything before that point, so from yesterday and before that. Sometimes, your data volumes are too large, or you don't have enough memory to be able to hold all of today's data in memory, and then you need to introduce this element in the architecture, which we call the Intraday database, to allow you to manage those volumes. And basically the purpose of this process is to be able to leave the real-time database to hold only a subset of today's data. It could be maybe the last hour or the last 10 minutes, while the Intraday database will hold everything else that's still from today. And it's usually divided into two processes. You usually will have a process that is similar to the historical database, will be able to query the data that you already have on disk for today. And then a process that is the responsible for actually doing the save down, so that you can have those separately. So usually the process that's in charge of doing that write down will read the TP log file into memory, right? So if, for example, you have designed that every 1 hour I want to save down data on disk, then every hour you will read from that new TP log file, and then you will save it down on disk. So it's a different database from the historical database that then gets merged into the main one at end of day. So again, there's multiple ways that you could design the way that this is being done. Like I said, you can decide how often you want to save this data intraday. You could do 10 minutes, you could do 1 hour, you could do 4 hours. I've seen some examples where it's done based on row count. So when a specific large table reaches a specific row number, then that gets moved to the intraday database. And I guess the one thing to consider here is if we go back to the gateways, right? In the previous diagram, you only had the gateway having to go to the real-time database or the historical database. When you add this element in here, you need to tell the gateway that there's a new tier and there's going to be certain data that will be in a different database. So you really want to think, how is the data being queried? And what your schema design is, that's going to impact how you're going to design this intraday database and what strategy you're going to use to save that data down. And yeah, I guess one tip, if you're doing it based on intervals and you're going 10 minutes or 1 hour, I would suggest doing that configurable because maybe today you have certain volume of data, but maybe in a couple of years the volume increases and you need to save that data intraday more frequently. You don't want to do a whole lot of changes, to the gateway, to the write down process, but making that configurable would make that easy.
Yeah, awesome. I don't know if you mentioned it. I don't think you did, but the white paper that's on Intraday Writedown is awesome as well. That's available on the code.kx.com website if anyone is trying to implement this. Also, Alex, is this something that you have seen implemented more often than not? Or what's your experience with Intraday Writedown?
No, I think Cynthia described it pretty well, like the different ways of having intraday write down, either on like time frequency or number of records. To me, it's still like, it's impressive that we have so much data that we actually need a solution like intraday write down. Like it's some of the production servers I've seen, they're like quite big and have several terabytes of memory actually, but we still need intraday write down solution, and to me it's mind-blowing.
Yeah, definitely. Okay, cool. I think we can move on to the next thing you might want to consider, which is not really processes we're adding now in this time. This is more about the database best practices. So it's really essential to obviously understand how you're saving down this data so that you can optimize the performance and things like that. So I think, Alex, you might kick this one off about the experience you have in data management and the things that people really need to know up front.
Yeah. So what I noticed often, and especially with more junior KDB developers, is they would actually be aware what attributes are and how they work and what they're good for, but then they struggle to see where in the KDB tick setup they're actually be used. So like general, it's not that difficult. Like best practices, you would have like your sorted attribute on the time column on the real-time database, and then a grouped attribute on symbol on the sim column, for example. And that's simply because your data that comes into your RDB isn't structured and isn't ordered in terms of symbols. Like you might get 10 updates for Apple and then a few Microsoft, a few Google. So like the only real attribute that's going to be helpful for optimizing your queries and increasing this like efficiency and speed of the query when you actually search for something is having the grouped attribute on a sim column, for example. When you move to the HDB, then at the end of the day, and you have actually the time, you can actually sort the data. Then you will sort your data by sim, and then within every sim by time, and then save it down into your HDB. So you would basically then apply the parted attribute on your symbol column. And those are pretty much the ways how you can optimize your queries. The reason why you apply the sort, like you might think like, okay, on the RDB, my data comes in a timely manner, so it's already sorted by time. Why would I have to apply the sorted attribute anyway? And the reason for that is that KDB, if you have a sorted list, but you don't have the sorted attribute applied, it will use the linear search rather than a binary search. So by adding the sorted attribute onto your time column, you will speed up your queries by telling KDB that it should actually use the binary search as opposed to the linear search, and then you're much, much faster. And pretty much the way how your RDB would receive those attributes or know which attributes goes onto which table is by defining the attributes in your schema file that the decaplant loads on startup, or the decaplant loads the schemas of all the tables into memory, and then each real-time subscriber that subscribes to the decaplant will actually receive an empty table schema with all the attributes that are applied to each individual column, and then have that table in memory. So that's pretty much how real-time subscribers get the attributes. And one thing to note is that all those attributes, except the sorted one, have some memory overhead, because in the background there will be some metadata stored. The grouped one is the most expensive one, because there will be a mapping from every unique element or key to the corresponding index in like the position of that element in the list. And because it needs to do that for every occurrence, this is obviously the most memory intense. Now, you can also apply more than one grouped attribute to a table, but you have to be aware that for every column you apply a grouped attribute, you will have this metadata to be generated. Now, why would you add more than one grouped attribute? Because you actually don't know how your users are using the data. You might have someone to query for symbols, while another one is interested in a trader, a specific trader, a specific ID. But how KDB works is only the first column that has the group that has an attribute applied. Once you get the subset back from the query, from your select clause, from your where clause, if you do select from trade where sim equal to something, and then trader equal to something else, the attribute only works on the first where subclause. So that's a reason why you might want to apply different attributes. Like to different columns, the group attribute. Yeah, and I think that's pretty much it on the attributes. The unique one is more it's not something you would use out, I would say, like on a regular basis, like whereas the grouped and the parted and the sorted is pretty much standard. You would have that in your tick setup. The unique, where I have used it, is more on when I have those real-time subscribers, when I do certain complex event processing engines, and I really want to speed up my queries, or like inserting data into a table, then I would use the unique keyword attribute.
Yeah, awesome. Cynthia, have you ever seen instances where people don't put their attributes on correctly?
Yeah, it's actually quite common at the start to not add any attributes. Maybe it's because of the complexity on understanding. And I usually am asked, what attributes should I add to my database? And the reality is that only the person who's designing the database and the people that will be querying that data really know. So it really depends on how your users will be querying, and there should be like a little bit almost like user research and understanding what data are you capturing and how it's going to be queried, and then design the attributes, because otherwise it's really hard. Like Alex was saying, usually you'll have the grouped or the parted attribute on the sim column. That's what we usually see in the financial services. But obviously, if you move on to other industries, there could be completely different designs. So it's really important to understand, how will the data be queried by your users to decide this.
Yeah, definitely. And on the deciding which format your table is in, so you have like partition, splayed, flat. I know we kind of talked about this, and maybe it's the same thing. Maybe it's user research on the size of data they're going to be capturing, which it probably is. But yeah, anyone want to talk about that, or anything they've seen, or any tips?
Sure. So the problem with the flat file is obviously as soon as your data keeps growing, then at some point your flat file will breach the memory limit you have. Like on you cannot store 20 years worth of data into a flat file. So then the next more granular, like the next way of storing is by splaying your data, which means you basically split the table into every single column. So you will have a folder. If you look onto the screen, let's say that displayed one there, it's representing it like the trade table. Each individual column would be saved down into a flat file, and the .t file will contain the order of your columns. Then if that still is not granular enough, you can use a partition database. So you would partition like the standard, like different ways of partitioning in the financial industry, or generally big data time series. How we have seen it is like you can partition by date, month, or year, or any numerical value. And because, like, temporal data in KDB under the hood are numerical values, that's why date, month, and year is the most common. So then the strategy for deciding whether you should partition by date, month, or year is basically, what I look at is how much data I'm actually getting. If I have, if I'm the asset class, for example, is foreign exchange, FX currencies, and you get trillions of records a day, there's no, it's not a good idea to partition that into a monthly partition. So you would have all the data for a specific month in that partition, because then, let's say you want to query the data for a specific month, it's just going to pull all that data into memory, and then either you run out of memory or it's going to take very, very long. So the more data you have, the more granular should be your partition range. So in that case, I would partition by day. If you have less frequent data, you might consider partitioning by month. And if you have even less data, then you might even consider to partition by year. But honestly, I've actually never seen a partition by year. By month, I've seen that. Maybe you're doing some, matrices. Again, you're running some matrices over a month for your users, and then it's absolutely fine to store them in a HDB that's partitioned by month rather than by day. There is the last one, the segmented one, that's not on the screen. It's only mentioned what it is in the table on the left, but not drawn on the right. But basically, it's simply
I couldn't fit it.
yeah, too much data, big data. Let's try with it. Basically, it's a partition database, but you can partition the data across different mounts. That's how I imagine it. You would have a part.txt file that has the link to your mounts, and then you would have on every mount the same setup as you see on the screen, with the only difference that the sim file will actually be in the root file, root folder, where the part.txt file is pointing to your different mounts. The sim file, for those who don't know, is basically all symbolic columns in your table, when you display them, have to be enumerated, and the sim file will be the file that contains the enumeration against the different symbols. And that's pretty much it in terms of how you can divide your HDB in splayed, partitioned, or segmented.
Yeah, amazing. And that obviously, it's not just for real-time systems, which is kind of what we're talking about today. Obviously, we have users who don't need a real-time data capture system, but these things are still really important because it's all about the historical data they have on disk. We did have a question come in. It's not showing up here, but I see it from John. Do you put attributes on the intraday database as well?
I'll take that one. So yeah, you would usually keep, using the attributes, because you're still going to be using that tier of your database for your queries. So you still want those to be performant. So yeah, similar to what Alex was saying, where your RDB and your HDB may have different attributes just because purely the data that is being contained in that process, you would do similarly with the intraday database.
Yeah, cool. I think we had one more question, which is related more to the previous slide about the RDB and the write-down. So is the RDB responsible for both EOI and end of day? So end of interval and end of day, write-down and merging, or is there some specific service that's not shown here? So
I can take that one. So basically, in the plain vanilla setup, the RDB would write down to the disk. But as your system grows and you want your RDB available all the time, especially, you know, nowadays where you have markets open 24/7 or close to 24/7, and the real-time data should be available all the time. If your RDB needs to write down to disk, the RDB is basically blocked during that period. So the more data you get, and the longer the write down will take, which then means your RDB isn't available for queries. So to avoid that use case, you can have an individual process, a separate process that's responsible just for the write down. This again has its pros and cons. The RDB already has the data in memory and could just write it down to disk, which makes it more faster, more efficient. If you have a different process that actually needs to write to disk, and it's doing that by reading the TP log file into memory and then saving down, obviously this will take time depending on the size of the TP log until it's loaded into memory and then written down. In the meantime, your real-time database is getting new updates for the next day and storing that in memory. So your general memory footprint is increasing, and you might reach the limits of your memory of your production box. So it really depends on your use case. Again, with most of the things we've discussed today, it's really a matter of actually sitting down and thinking about what you want to do, what you need to achieve, speaking with your users, what's important to them. Depending on the asset class, for example, in equities, when the market closes at the end of the day and users might not query the intraday data anymore, or all your reports have run and you have like some gap where there are no queries against your RDB, it might be best that you decide the RDB is writing down to disk. But then you might have systems where you have FX data and the users are across different continents, different time zones, and they're always querying your real-time data. So you cannot really have like an RDB being blocked for 2 hours because they need to write down to disk. So I would say it's again like a discussion between the system architect and the users and a KDB technical lead, and then figuring out what's the most important for your use case and how you want to solve it and which battles you want to fight.
Yeah, for sure. Thanks so much. Was there anything, Cynthia, you wanted to add on to that, or I think you covered it all there? Yeah. Cool. Let's just skip back forward. So that I'm aware we're reaching the hour mark shortly. So just before we wrap up, I do want to just mention, so everything we've talked about today applies to, obviously, if you're building your own custom architecture, but also there are a lot of off-the-shelf products available that offer pre-built KDB architectures like KDB Insights. We have Delta. There's also Refinery and AWS FinSpace. And these are commercial solutions, but they're built on the exact same foundational architecture that we've covered today. So they're relevant whether you're setting up a new system or optimizing an existing one. You'll get the most out of your product if you start to understand some of these core components as well. And I did actually get a question on software as a service, I think, from Sakin. So Sakin's asked, could you provide a brief about KDB as SaaS on Azure or AWS? That actually was my next slide. I promise I didn't plant that comment. Yes, so while it's not software as a system, but it's platform as a system, so PaaS. So that's what AWS FinSpace provides. It's a native managed service available for anyone from AWS, and it really supports all KDB architectures, so everything we discussed in the webinar today. And it's about either bringing your KDB architecture to the cloud, so if you have an existing one and you want to be up and running in the cloud, or if you're building it from scratch and you don't want to worry about things like building in monitoring or the logging, or I guess with the cloud, it's auto scaling and managing all of that recovery as well that we kind of talked about today. So the benefits that AWS brings help you focus on the other parts, like building your business logic, and not so much on the managing or support element of your architecture. So it's just really a way to make managing your costs and the service easier. So do check that out over in the AWS website if that's interesting to you. If anyone's interested in finding out more about that, just let us know in the comments and we can have a conversation. Or if you want to, check out our new Slack that we just launched last week. Me and Cynthia and Alex are all over there. So if you want to have one-to-one conversations with us or any other KDB developers, we talked a lot today about user research, and you need to really evaluate, your setup and have a KDB technical expert. Maybe that's not always possible for some customers, or people are just trying to prove out concepts before they get to that stage. So if you need some KDB expertise, or you have your use case in mind, if you want to, get some help on the Slack community, we've got some awesome people over there. And this is in addition to our other ways. So we already have our KX community forums. We have a subreddit. They're all staying in place. We just want to offer some more ways that we can communicate with you and keep the channels open for conversations so we can all learn from each other. So yeah, I think that's a good place to wrap up our session today. Huge thanks to Cynthia and Alex for sharing their really valuable insights. I hope everyone found this session really useful. And if you do want to go try out the course, let us know what you think. I'll be hosting more LinkedIn live sessions like this one, talking to different users and experts, learning from their experiences. So if you have any suggestions for what you'd like to see in future live streams, do let me know. Again, message me on LinkedIn or on Slack or in the comments. And yeah, that's it from us. Until next time, thank you so much for joining, everyone, and for your comments, and take care.
Thank you, everyone. Thanks, Michaela.
Bye.
Thanks.